Thank you. And great introduction. I might just build on it by telling everyone I'm a reformed engineer. That was my attempt at humour. You need to laugh. And look, most of the details I've got in the pack are readily available on the respective websites of the two networks that I look after, Energex and Ergon. There's a lot of detail in the slides. I don't intend to talk to all the detail. What I want to do is to bring out a few key points, maybe tell a few stories, and at the end I might just get a little bit controversial just for fun at the end of the day. So just briefly, Energy Queensland is the amalgamation of two networks, Energex and Ergon. I'm not going to go into all the stuff about RAB because that's really boring. I'm going to talk about the fact that I've got 2.2 million customers and I've got 460,000 customers with solar panels on the roofs. So if you do the numbers, that's about 25%. And that's about 355 megawatts of solar panels on roofs, and I've got, right at the moment, if I actually did the maths, I've got about 3 gigawatts of large-scale solar looking to connect to the network. So solar and how we manage solar is a big part of the challenges that we're facing, and we're committed to helping those proponents connect to our network. So this morning I heard this concept of energy-rich, transferring of costs, and that's really a big part of our challenge. And the other part is that the Energy Queensland covers a vast variety of different types of communities, from downtown Brisbane CBD all the way through to very poor communities in the very far north of Queensland. So it's some interesting challenges there when you try to solve the problems for what is a very diverse group of customers. So let's have a look at the numbers. So in Queensland we have been doing demand management in one form or another for about 70 years. It started off as a very much a top-down response to managing an end-to-end supply chain with a vertically integrated government-owned business. Today it's a very different outcome. We've retasked that technology to do something that's really quite smart, I think. Just so the high-level numbers, I've got about 850 megawatts of controlled load. Of that, most of it is legacy hot water stuff, and I'll talk about how we've repurposed that in a minute. I've also got, at the moment, about 58 megawatts of peak smart air conditioners under control in southeast Queensland. So that's quite embryonic. We've been doing it now for a few years, and customers have really still signing up to it in numbers, and we've just taken that program Queensland-wide. So they're pretty good numbers, and they certainly help us manage a number of different contingencies that we face every day. So a lot of detail in this slide, and I'm not going to talk to it all. I think the first thing I'll pick up on is, the previous speaker talked about it, is working in partnership. So our Peak Smart program is done in partnership with both the manufacturers of the appliances and the retailers. So Harvey Norman, for example, when you hear an ad for an air conditioner, you'll hear Harvey Norman advertising the Peak Smart program because it's good for them and it's good for us. And Larissa this morning commented that, and it really resonated, that customers want simple, set and forget solutions, and really giving people upfront rebates to assist them purchasing new energy-efficient appliances is exactly what we get with the Peak Smart air conditioning program. Customers get an incentive to put some control. It's an upfront payment. It's set and forget from that point. And if they buy a modern air conditioner, it's probably 30 to 40% more efficient than the one they're replacing. So that's a real benefit as well. And there's been a lot of discussion in the press about turning your air conditioner off when it's 40 degrees, or, I did laugh when I heard the Victorian numbers. 20% humidity? I think last week. I think last week in Queensland it was like 80%. Anyway, sorry, I'll stop picking on that in a minute. I've got everyone listening now. So I was talking to my 88-year-old father the other day because, not surprisingly, he's got a Peak Smart air conditioner. And I said to him, so how's it going? He said, working really well. I said, that's good. And then I said, so do you notice when we turn it off? And he said, yeah, I do. I said, I got worried then. I'm thinking, uh-oh. And And he said, yeah, I can see the lights change on the air conditioner. I said, so you don't notice any difference in how the room feels? He said, no, I can see the lights change, that's it. And really that's what our customers experience, and that's why they're continuing to sign up, because it's not like I'm turning their air conditioner off. All I'm doing is changing the amount of energy and the demand that's driving for a very short window of time. And there's energy stored in the room, and we turn it back on before customers notice the change in temperature. The other thing that's really quite clever about what we do is, and it's in that bottom graph, I've got network running backwards in the middle of the day, or I would have it running backwards if I hadn't shifted the hot water load from being in the old peak, the old peak pricing period in the evening, to sticking it in the middle of the day. Because sticking it in the middle of the day is where there's lots of excess energy floating around, so you soak it up and store it in a hot water system. Working very well, and it's been a very, very cheap way of enabling us to continue to connect solar to the network without spending any money. So let's talk about peak demand days, and I promise not to mention fuses too often through this piece. Just to clarify, there's and it really resonated with this morning. We're very much a closed ecosystem of professionals, and we talk jargon that people don't get. So when someone says a demand response day, we assume everyone knows what they mean. And the previous example of a demand response day, and we've had a couple of these recently in Queensland as well, is you get this generation. Generation is not quite there to meet the customer demand, and if a generator failed, there wouldn't be enough and the lights would start to go out. So that's when you have a signal sent out and you look for customers to drop their load to avoid that blackout. There's another type of blackout, which is when the network fails. That graphic on the screen there is the Queensland peak demand last week, and it was another record, and we would have had another record the next day if it wasn't for a storm. Key point I want to make is that the technology we've got out there actually allows us to not only help when we need to avoid generation shortfalls, it gives us the absolute tools to manage local network constraints, to avoid problems at the local region in terms of distribution transformers and zone substations. So a demand response event isn't just about generation, it's also about making sure the network doesn't burn down, literally, and if the network does go black, then everybody loses. So in my last slide, and this is where I'll add a bit of humour and maybe a bit of controversy. So dread sounds really bad, doesn't it? You're like, really? Who came up with that name? So it means demand response enabled device. I couldn't come up with a worse name if I tried, but it's good for a story. So this is the device. It's a little device. It's about that big, and you wire it into an appliance. So it's wired into your air conditioner or your pool pump, and that little device picks up a signal that we send down the power line. That's as technical as I'm going to get. And those devices could be anywhere. And down the track, there's this theme that says someone should own demand management. Like someone should own the customer actually owns their own demand management experience. It shouldn't belong to the retailer or the network business or the next person with a product to sell. And in fact, I actually think that it's likely that customers can have any number of different devices that can control their loads at their choice. And I think choice is one of the words that came up this morning along with simplicity. And I know absolutely that the engaged customers will have home energy management systems, and many of them have got them today. I know absolutely that there'll be VPP products and flow power products, and they can all operate together. There's no reason that they should be not operating together. What I do know is that if you want the network not to go black, the network business has got a place in this space to make sure that if the market doesn't act the way you expected, and let me tell you, in Queensland last week it didn't, then you can actually take control to make sure that the network doesn't go black. Because if the network goes black, no one's trading anything. So that gets me to the boundary of control point that I want to make. And really, it should be customers get to choose, and under the current direction that we're taking demand response in Australia, customers may not be able to choose the solutions that they've been saying yes to and have been delivering great benefits in Queensland under the way the rules look like they're heading. I might have a solution though, because I understand that behind the meter is actually physically behind the meter switchboard. So that might solve my problem if I adopt that definition. Key point is that I think it's really important that we acknowledge that we've all got a role to play in delivering better outcomes for customers, both in terms of security of supply, both security of the network, security of the generation and load balance, giving customers the opportunity to maximise their benefits out of DR. And the Peak Smart program has demonstrated the benefits of simplicity, set and forget, and I think it's great that we can provide an upfront incentive to help people lower their energy bills at the same time, and that's what we're doing in Queensland.